Okay, so here we're going to prove the difference formula for cosine, and a bunch of things follow from this. So it's a nice building block. Let's say this is an angle beta. This is an angle alpha. And we want to look at the cosine of alpha minus beta. So what is the cosine of alpha minus beta? So first of all, let's just note down a few things here. This, of course, would be cosine beta, sine beta. This point here would be cosine alpha, sine alpha. And if I reorient this drawing, I'm going to try to just sketch it real quick. The orientation is really important. Key link here is that if I look at just this angle, that would be alpha minus beta. So let's just say that's somewhere over here. This is alpha minus beta. And the key is that this little guy is the same distance as this piece here. Okay, so now all we have to do is compare those two things. Now, of course, this point is 1, 0, and this point is the cosine of alpha minus beta and the sine of alpha minus beta. So I'm going to put this piece back here. Yep. This piece back. So now all we need is the distance formula. And I don't know what you remember about the distance formula, but if we have a point here and a point here, let's call this x1, y1, and this x2, y2. We find the distance by basically using the Pythagorean theorem. We find the difference between x2 and x1, square it, add it to the difference between y2 and y1, square it, and then that's going to be the distance squared. So we take the square root of the whole thing, and that gives us the distance. So I'm just going to do that for this segment over here and this segment over here. These are equal to each other because all I did was I kind of rotated that part back to place this onto the 0 reference line. Okay, so let's go ahead and work it out then. So in the first one, the black line, number 2, we've got cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared, and square root of all of that. That's the distance of this line here, called D2. Okay, well, let's look at the D1. So this one is cosine of alpha minus beta minus 1 squared plus the sine of alpha minus beta minus 0. So do anything squared. So basically, because these are really the same line segment, I just can set these equal to each other. And the first thing I'm going to do is I'm going to square both sides to get rid of the square root. The next thing I'm going to do is I'm going to actually multiply out each of these squared terms. There's nothing really to do here because there's no subtraction in that. But the other ones are going to come out as trinomials. All right. So let's And you're welcome to pause and see if you can derive this yourself at this point. So we've got cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. That's one side equals cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1 plus sine squared alpha minus beta. Now remember, the notation for squaring is, the convention is to put it on cosine and sine, because I don't want to confuse whether it's alpha squared or cosine squared. Cosine alpha is cosine alpha times cosine alpha. Sorry, cosine squared alpha is cosine alpha times cosine alpha. Now, Pythagorean theorem is big here. I'm going to circle all the pairs. This is 1. This is 1. And this is 1. Right? Because if I have cosine squared x plus sine squared x, that's equal to 1. It doesn't matter what the angle is, whether it's alpha, beta, or alpha minus beta. So this is going to clean up a lot now. D2 here. So we've got 1 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta plus 1 equals 1 minus 2 cosine alpha minus beta plus 1. It's a lot to simplify because I've got ones matching here and here. And I'm going to divide both sides by -2 and end up with, I'm going to put the cosine alpha minus beta on the left is equal to cosine alpha cosine beta plus, dividing by -2, so this all turns out positive, sine alpha sine beta. Okay, so that's a pretty remarkable result that comes just from looking at the geometry and the distance formula. You can test it out for yourself if you want. You can try some values here, degree mode, radian mode, whatever. Degree is probably easier to do, but for instance, you could do cosine of 40 minus 10 equals cosine 40 cosine 10 plus sine 40 sine 10. And of course, cosine 30 is a value that you can get right off the unit circle. It's a square root of 3/2. So you can compare this value, cosine 40 cosine 10 plus sine 40 sine 10, to the square root of 3/2 and see if it works. I'll do it right now. See what happens. All right, next up, we're going to take the cosine difference formula, turn it into the sum formula, then look at the half angle formulas and turn it into the sine sum of difference formulas. I'll see you there.